Alright, so you need to allocate the process to the appropriate nodes, that means distributed system. And also you need to have a good resource allocation. How do you allocate the resources? Your resources not only the CPU that you allocate, you also allocate other resources like for example memory, as well as maybe printer or whatever. So you need a good way to allocate the resources. And in order to ensure that they don't run into risk condition, we have to use one of the mutual exclusion algorithm. Say for example token passing, in this case because you're doing distributed system, right? So if you use distributed system, you have to use token passing in order to ensure mutual exclusion. Okay? You also need distributed scheduler in order to run them or maybe allocate or maybe distribute the process, okay? So that you load the system with the appropriate amount of tasks to perform the job. Okay, these will require network connection, and therefore you need local area network or maybe wide area network. Okay? Now, of course, local area network is the best because it's faster, but most of the time your distributed system is not local. It can be all over in the network, and you will need wide area network. Okay, one of the problems that you always going to face if you do a distributed system is how do you migrate the process. Okay, there are two types of migration. One is live migration, that is the most difficult one. And the other one is you migrate before you start the program, and that is the simplest. Before you start the process, you migrate the process. But when it is already started, you want to migrate, that is the hardest to do. And you will see some of the technique to do or that you can use in order to do live process migration. Okay? What do you need to migrate the process? We'll see some of the reasons. One of the reasons is you don't have enough of resources. Okay? That's why you need to migrate from one computer to the other. Or you specifically want to execute on that particular target machine, then you do migration. But these are the motivation for the migration. Okay. The first thing is load sharing or load balancing, which is missing there. Actually, it's load balancing and load sharing. What are the differences between the two? I'll explain later. So, if let's say you have one computer is all loaded. It's a web server. Everybody is using that web server, only one web server. Then you will have problems, right? Because everybody is using it and it's overloaded. It's going to service everybody very slowly. Okay, so you might want to load share or load balance. It means you have multiple web servers, and every web server is serving one small portion of users. Okay, so that is load balancing and load sharing. So it's missing that load balance. The second thing is you want to consider increasing your communication performance. Okay, maybe I'll go into the slide like that. So this is a load sharing. You want to move process from heavily loaded to lightly loaded system. So this is load sharing. So this will improve significantly if, let's say, your processor is not overloaded. Okay? If your processor is mildly loaded or moderately used, you can gain a lot of performance there. Once everybody is, once the computer is overloaded, you will not get any performance improvement, right? So you want your process to be distributed among the distributed system that you have. So that each process, each computer is lightly loaded. Okay? But you must be careful when you do this, because you must make sure that there is no communication overhead when you do the load sharing. Okay? Okay, the second reason or the second motivation is communication performance. If you have processors that is communicating a lot, let's say for example, this node here and this node here, they are very close by to one another, and it's using the database. Let's say here is the database. This is your database. And the process is running here, right? So this is LAN, for example. And very close by. And we have another process here, and we are using this database, let's say. Okay? So you want this process to be here, you don't want to be very far away. Let's say this is the cloud, and we have another process here, P1, P2, P3. Sorry, I should say this one P4, P5, P6. And they are also using this database. This database and that database, but they are maybe very far apart. Maybe this one is in Malaysia, this one is in Japan. Yeah? And they are using this database. What you want is to bring all this process close by. That means you migrate this process maybe to this computer. So you got P2, P4 running here. So you don't have the process running here. This is a computer. And then you migrate this maybe to here, P5 is here. Okay? And then P6 maybe you migrate here. You can migrate here as well, but you want to look balance as well, right? So you got two processes here, two processes here, two processes here. Because all of them are sharing this database. So you want to migrate from Japan to here so that you can actually access this database more efficiently. That's what I mean by communication performance. Okay? You migrate because it's very long, very far, and it requires a lot of resources when you transfer, especially large database. Okay? When you transfer quite a large database, you will overload this network. Yeah, of course, I know that nowadays our network is quite fast. We have a lot of bandwidth here. But if you move closer, then you can actually relieve a little bit the internet, right? So you better move your process or your data closer to where the data is. Okay? Or maybe move your data to closer to the process. But most of the time you move the process better than move the data. Okay, the third one is to look at whether you have the resources available. Let's say, for example, in Japan, you got earthquake always, right? Then you got a power outage. Then your process that is running here, if let's say there's an outage, it's going to be gone, right? So you better move your process to somewhere else, maybe to Malaysia again, or the surrounding country that does not have this problem. So you move this P4 from Japan that is having earthquake to another place. So that is availability, meaning that here it's not available because of power outage because of earthquake, for example. Okay, that is what it means by availability. And another reason why you need to migrate is because maybe this computer here got GPU, okay, or maybe it has a printer. Here you got printer to print certain things. Then you might want your process to run here, or maybe the process run in the printer itself. Okay, or maybe GPU is right over here. Then you go to use GPU, right? So you move the process into this computer so that you can fully utilize the GPU. That is utilizing special capability, right? So the motivation of why you need to migrate is all those four that I mentioned. Okay, the first one is because you want to load balance, so that is the process is running on a computer which is not overloaded. Second is because you want to move nearer to the resources that you have, so that you don't have to transfer the data and overload the internet. The third one is availability, meaning that you have an infrastructure, but then there's some natural cause, which cause it will not be available, so you have to move it away. And the fourth one is to use the special hardware or software on that particular computer, or you need some special capabilities, then you migrate to that particular computer. So you need this migration, alright? So the migration issues is there are a number of things. One of the main issue is who is going to initiate this migration. This may be not so difficult. But what is involved when you do the migration? Okay? And if you migrate, which portion of the process that you migrate? Do you migrate the whole thing or you migrate some stuff? And the fourth one, what happens if, let's say, it is a live migration? That means the process is running, and then you have to migrate it. For example, I mentioned that the process is running in Japan, then there's earthquake, you have to migrate it while the process is running. Okay? So when you migrate, the time there are messages that is sending across, right? So let's say somebody is sending the message to your P4 here, it's coming, but you already migrated. What happened to this message? Is it going to be lost? Or is it going to be recorded somewhere and then pass along to, eventually pass along to where it was migrated? So these are the fourth one. Okay? The outstanding messages and signals that is going to pass around as you migrate. Will it be lost or will it be successfully forwarded to the migrated final destination? Okay, the first one, who is going to initiate the migration? Actually, this is quite simple. It's either the OS or the process itself. Okay? So it depends on the goal there. If it is OS initiated, most probably it's because you need to do load balancing. Because process will not care about the computer whether it's overloaded or not, right? Only the operating system really care about it. Okay? If let's say the operating system find out that this PC is overloaded, then you better do load balancing or load sharing. So you start to migrate the process to other computer which is available to lighten the process. So if OS is initiating it, most probably it's because of this reason. Okay? And when it is done, normally it's transparent. So your process will not know that it has been migrated. So it can be live migration, it can be also migration before the process starts. Okay, so there is a load balancing on data sharing. Sorry, load sharing. The second one is process that initiate this migration. And normally process initiate is because you need that particular resources. Let's say, for example, the GPU or my GPU. OS will not know what the process is requiring. Right? Only the process knows that it requires certain resources. So this process knows that you go to this GPU, for example, special resource. So it has to migrate itself to another system, distributed system. So this is requiring the process itself to be aware of this migration. So it has to do it on its own. So this is process initiative. Okay, this one is harder because the process itself needs to do the migration. This one is simple from the process perspective because the OS is going to do the migration of the process. So the process need not know that it has been migrated. Okay? So who initiated the two, OS or the process? Okay, the next issue that we need to look into is what is going to involve in the migration. Okay, when we do migration, it's not replication. Replication and migration are two different things. Okay? Replication versus migration. Okay, replication, of course, we don't discuss it. We replicate it because we want to have multiple service to the many requests from the client. Let's say client, you got 1 million clients, then you replicate. Okay, let's say for example Netflix, we replicate it, let's say in Asia, we replicate maybe Netflix here, Netflix in Japan, Netflix in US, so that if you have clients that want to watch Netflix, you'll be using the replicated Netflix that is available in the country. Okay, so that is replication. That means you've got multiple copies. Now how about migration? Migration is something similar to replication, but it's different in the sense that when you replicate, you destroy the source. That is migration. That means you move from one place to the other. You have to remove your process that is running on the original source. That is migration. Okay, so that's the difference between migration and replication. So you must destroy the process in the source and you create a new one in the target system. Okay? And what you migrate two things. One is the code, which is the process image, the code, the source code that, the code that is running the process. And also the context of the process, which we call process controller, PCB. Right? And any links that is involved in the processing. Okay? One thing that is missing here is the data. So not only the process image that you need to transfer, not only the process control block that you transfer, that is the context of the process, you also need to migrate the process inside the data itself, the data that is used by the process. So this is an example of, simple example of process migration. We've got two machines here. So here it looks like it's not balanced. Here are more processors, here are less. This is before the migration. After you migrate, you choose this, you migrate that one across. Now it looks like more balanced. Right? But you have to also consider the communication overhead. Because when you migrate this, you can see here, this process communicate with these three nodes or three processes, right? From two different machines. After you migrate already, it's balanced, and the communication here also reduced. Here 3 to 2. Okay, most probably this is a better distribution of the process. Okay, not only is balanced, the communication overhead is also reduced slightly. Okay, this is just a simple example. Okay, so what is migrated? What do you migrate? You migrate process control block, of course, the image itself, that means the code that the process is running. You migrate that. You also migrate the process control block, which is the context of the process. For example, the register, the resources that is held by the process is also migrated across. Okay, there are several strategies that you can take. There are 4 you actually don't know. But this 4 is the one that maybe is popular. The easiest one is the top here. Eagle, there are one eagle that that's why there are 2 different types of eagle. Eagle O means you migrate the whole thing first, okay, and then you run the new process at the target machine. Let's say, for example, P6, migrate to this computer here, okay. So the whole process, including the data that you have and the process control block, you transfer into this computer first, then only run. That means you have to wait until all the transfer is completed, then only run. Okay? While it is transferring, the process cannot run. So there's a wait there. Okay? So that is the simplest of all, eagle all, meaning that you transfer, while you're transferring, you cannot execute, you have to stop. You stop the process and then transfer the only. If let's say it's 4 gigabyte, you have to wait until all those 4 gigabyte of information, including the source code, into this computer, then only you start to run. Okay, so that is eagle. The simplest and straightforward. Okay, the second one is free copy. Maybe I go through the slide. So eagle all is this. Transfer entire address space, that is the whole data, including the code. And nothing that is left behind. That means when you migrate, this copy here will be removed. Right? If the address space is large, then you have to wait. Maybe minutes, maybe a couple of hours, if let's say your network is slow. Okay? Now what happens if let's say it's already running? If let's say you haven't started, then it's okay. You migrate and then you start to run the program. But what happens if let's say it is already running? There are two techniques. One is to run until certain checkpoint and then migrate. Okay? What it means is, let's say this is your code, right? And here is the checkpoint. And then here is the checkpoint. So the checkpoint is a place where you can safely migrate. So while you're executing this code, you cannot migrate because you are doing the work halfway. And this can cause a lot of problems if you migrate at this position. Okay? So you have to wait until the CPU reach this checkpoint. Now it is safe to migrate, and then you migrate. Okay? So when you reach a certain checkpoint, then you can migrate. That is what it means by this checkpoint. Okay? Now if let's say your system is more advanced, it can migrate when it is here. Okay? But when it is here, there are certain data, when you migrate, it will be destroyed. Because you compute halfway, right? When you migrate, this information is lost maybe, right? Now, if you have a restart capability, that means you can restart all over again. You can recompute the whole thing again. Then you can use this restart capability. That means you can migrate anywhere where the program is running. It doesn't matter. Okay? So that is more advanced, and normally it's much more difficult to implement. This one is more difficult. The checkpoint one is a little bit simpler because you get past all the difficult part where it's very hard for you to migrate. When you reach this checkpoint, it is safe to migrate. So you start to migrate when you reach this point. So that is what it means by checkpoint, and restart capability is used when you do this either or transfer. This one is provided that your program is already running. If your program is not running yet, then this one is not needed. That is the simplest one. So the best time to actually migrate is when the program hasn't started. If your program already started, then you have to come up with all this sort of algorithm in order to ensure that your migration is successful. Okay, so either or is not so good because as you migrate, you have to wait until the transfer process is completed. Then only you can start. If let's say you have 4 GB here, you transfer, let's say 4 minutes or 16 minutes, you have to wait for that 16 minutes to pass until the migration is successful, then only you can start the execute. Okay, during that time, if let's say this is a web server, everybody has to wait. Right? It's out of service during that 16 minutes. Okay, it might not be a good idea to use either or. Okay? Most probably you want is pre-copy. Okay, pre-copy, the process continue to execute on the source node when it's still running here, while the address space is copied over. That means as you copy, it is still running here, not here, right? Because you cannot run here because they are still copying, right? Okay, they are still copying, it still get transferred. So here we have one copy, here we'll have a new copy, but it's still transferring. And while at that time, it is running this program. That means if there's a web server here, nobody is going to wait. The person is going to able to access this web server still while it is migrating. Okay? Now, let's say for example, while you're migrating, right? And somebody write into certain data here. But you already migrated that data across. But here it has been changed. That means what you transfer here is a stale copy because the process is modifying the code while it has been, that means it has already been transferred. In that case, you have to send again. Okay, you have to send again that copy that you already transferred. Okay, pages that is modified on the source during the pre-copy, you have to copy the second time, or the third time, or the fourth time, depending on how many times that you change it, and whether it has been transferred already. If the data hasn't been transferred yet, and you change it, it's fine. But you already transferred and you change it, you have to transfer it again, so that it is consistent. Okay? So this reduces the time that the process is frozen. Remember, in either or, while it is transferring, the process is not running, it has to be stopped. Pre-copy is different. While the transfer is happening, the source process is still running. Okay, during that time, you don't encounter this frozen issue. Okay, during the process of migration, it is still running. But what is the disadvantage of this? The disadvantage is you have 2 copies in the lifetime of the transfer, because you cannot destroy this copy while it is transferred. Okay? Week08 is different. While you transfer, you can delete it. You transfer another batch, another portion of the code, you can delete it. Okay, so as you transfer, you can actually delete and free some of the resources. So a pre-copy has a little bit of disadvantage, is that while you do the transfer, the 2 copy must exist, because the source needs to be executing the code still and serving the customer. Okay, but the advantage of pre-copy is you don't have this frozen issue. That means there's no stalling in the process. Okay, but then that can be a problem as well, because while you're transferring, you have to transfer the whole thing. Okay, so this is running, and you have to transfer the whole thing. It's not so good. We have another strategy we call eager dirty. Eager dirty is slightly different. You still transfer, but you only transfer the portion of memory that has been changed. Okay? Let's say, for example, you touch that memory, you change that portion, and then you transfer it. Alright? If it doesn't change, then you don't transfer that particular part. Okay? So this one is good if, let's say, your code is big, but then only certain part is changed. Okay? You only transfer that part that has been changed. Okay? Transfer across. And then when you transfer across, of course, eventually you run here. But the changes that you make there is also visible at the destination part. Okay? So this is to avoid the copies here to be the latest and the copy here to be the old one. Okay? Because you always want to have a consistent view of the data during the transfer or during the migration. Okay? The source is involved in the process of migration. Throughout the migration, it has to maintain this pages that is dirty. Dirty means here you already touch it. That means you modify it. That is the meaning of dirty. Okay, once you touch the memory, that means you modify it, then that data is modified. That means the data becomes dirty. Okay, another one is copy on reference, which is I think much better. This is a variation of the eager dirty. The difference is this. If, let's say, you migrate, right? You migrate, okay? And then you reference it, that means you touch this memory. So that memory that you touch, because you need it, you will migrate first. You will migrate over. So you select the one that you recently touched, migrate over. Okay? The one you touch less will be deleted. So eventually everything will be migrated, but it will migrate according to priority, looking at what you touch. So that is copy on reference. That means once you touch the memory, then you copy over. That's what it means by copy on reference. Okay? Pages are only brought over when you reference it or you touch it. Touch means you either read it or you write it. Okay? So this one has the lowest initial cost of process migration, because most probably your program is going to touch a little bit of your memory. You will not touch the whole 4 gigabyte memory, right? So only the after portion is transferred. Okay, when you touch another part of the memory, you get transferred. So eventually, slowly, it will get brought over to the new targeted system. But eventually, all will be migrated, but you migrate the one that you touch most often. Okay, so it's priority-based kind of migration. Okay, the last one is flushing. Flushing actually is a process of doing virtual memory, where you don't have enough memory, but then you make it as low as you have enough memory. And that memory actually is on the secondary storage. So what you do, you flush it into the disk. Okay? Let's say this is your memory. Okay, you have only this much. This is the physical memory. But if you use virtual memory, it appears to be larger. Okay, so this memory actually is not available. This memory is inside the secondary hard disk. Okay, so if you touch this memory there, you will flush this into the disk, and then you load the new one into here. Okay, so when you load into here, basically you're flushing out and flushing in, flushing in, flush out and flushing in. Okay, this one is easy because when you flush out, it's inside the hard disk already. Okay, so when you do the migration, the other process is just reading the hard disk. So you don't have to worry about the ongoing process that is running in the memory by the CPU. Okay? Because once it's flushed into the memory, you just copy over from your secondary storage into the new process. Okay, flushing is a way to actually simplify the migration process. Okay? And another good thing about flushing is this: you don't carry everything inside your memory. Okay? Once you flush, it goes to the secondary storage. So your memory inside the CPU is, your computer is free. So you can actually use it for other purposes. Okay, so that's the advantage of flushing. But it has the similar advantage as the rest as well. Okay, so choosing the strategy is a simple advice. If the process is not using much addresses, while it is on the target machine, then you better use eager ready, copy of reference or flushing. Because this tree actually copy only the necessary into the target and then run there. It doesn't transfer all at once. It transfer the one that you need at a particular time. So those three strategy or the algorithm is the best for this kind of situation. Otherwise, if you use all the memory at one time, then no choice. Rather use a bigger or, that means you freeze your process that is running, transfer the whole thing, and then start the process again. Or you use pre-copy. One thing good about pre-copy is while you are transferring, you are still running. Okay? So that is the advice that is given. Okay, this is just asking you what strategy to use. If let's say you have this kind of situation where you have a file that is need to be migrated but is locked at that time for exclusive access. That means if one thread is or one process is running it or using it. So what strategy do you recommend for this? Okay. One of this, which one that you would recommend? Okay, the one thing that I did not talk about is what happens to the messages and the signal in the process when you are migrating. Maybe the message is coming to this computer, it doesn't know that you're migrating, right? So you're migrating to another computer in Malaysia, but the messages is still sending to this computer. So what's going to happen to that messages? So you need a way to temporarily store it here first, and then divert it to here. Okay? So either the operating system need to do it, or the process itself need to do it. Okay, you have to maintain this forwarding details because it knows where it is migrating to. So the process still need to run here to keep track of these messages that is coming in. Okay, so that these messages is not lost. If let's say you migrate and then you forget about it, so those messages that is coming still will be lost. Okay, because you need time for the transmitter to realize that you already migrated. Okay, unless you wait for all the transmitter is make note of your transfer, then you transfer, which is not easy. Most of the time you transfer yourself first, then you migrate first, then slowly you tell the transmitter that you are actually migrating, so that it can change the address. Instead of sending to this computer, you send to this new target system. Okay? Of course, you have many different ways. This is one of the ways. Okay, so what is the what make you decide to migrate? Okay, the decision can be made by any entity. It can be by the process, okay, for reason of load balancing, or it can be by the process because the resources that you need. For example, the GPU. It needs the GPU here doesn't have GPU, have to migrate to here because the GPU is there. So the process need to make its kind of decision. This one they discussed just now. Or some system let the system decide, participate in the decision. That is requiring some kind of negotiation between the two parties. Maybe this and this, we will need to discuss first, negotiate between them. Okay, this need to request, or this need to approve. If it doesn't approve, you cannot migrate. Okay? So the decision depends on the how you implement it. So that is the migration policy. Right? So migration by negotiation requires the starter, that is the person to migrate, to start it, and then the decision on the receiver side also needs to be taken into account as well, because it needs these two systems to agree that the migration happens. You cannot just migrate without any information. So there is some kind of policy that is in place in order to do this migration. So this migration by conversation. So this